Hello everyone, and welcome back to the Fluctus Channel. The M1 Abrams main battle tank stands as a symbol of American armored power. Developed in the 1970s by Chrysler Defense, it entered U.S. Army service in 1980, replacing the aging M60 series. Powered by a Honeywell gas turbine engine, it offers unmatched speed and agility for its weight. Its Chobham composite armor provides superior protection against modern threats. Armed with a 120mm smoothbore cannon, advanced fire control systems, and thermal sights, the Abrams dominates in both day and night combat. Constantly upgraded, it remains the backbone of U.S. armored forces and a benchmark in modern tank warfare. M1 Abrams main battle tanks are operated by a crew of 4. The commander, gunner, loader, and driver. Each member plays a vital role in ensuring the 70-ton war machine performs with precision. The driver, seated in the hull front, controls movement using an aircraft-style yoke. The loader handles ammunition and ensures the main gun is ready for rapid engagement, while the gunner and commander operate targeting and fire control systems that can engage multiple targets simultaneously. Despite its weight, the Abrams is remarkably agile thanks to its 1,500 horsepower Honeywell gas turbine engine, allowing speeds over 40 miles per hour on open terrain. Its advanced suspension system gives it the ability to cross rough ground, obstacles, and even shallow water with ease. Protection is provided by Chobham composite armor, layered with depleted uranium inserts, offering exceptional defense against both kinetic and chemical energy rounds. Features such as blowout panels and ammunition storage, NBC, nuclear, biological, chemical, protection systems, and infrared vision enhance crew survivability. Equipped with a 120mm smoothbore cannon, computerized fire control, and thermal imaging, the Abrams delivers pinpoint accuracy. Its blend of firepower, protection, and mobility continues to define modern armored warfare. Upgrading M1 Abrams tanks extends their service life and keeps them effective against evolving threats. Modernization programs focus on engines, electronics, weapons, communications, and survivability. Replacing legacy components with digital fire control, improved thermal sights, and networked battle management systems increases lethality and situational awareness. Powertrain upgrades and improved suspension reduce maintenance and enhance cross-country performance. Installing reactive armor provides an additional layer of protection against shaped charge warheads and certain kinetic threats. Reactive tiles work by detonating on impact to disrupt incoming jet formation or blunt penetrators before they reach the main armor. Fitting reactive armor requires structural assessment, reinforcement of mounting points, and integration with existing armor and vehicle balance. Engineers must ensure tiles do not interfere with mobility, crew access, or onboard systems. Ammunition stowage and crew safety measures are reviewed to accommodate new blast dynamics and handling procedures. Field tests and trials validate performance and identify unintended effects like increased weight or altered thermal signatures. The overall process balances protection gains against mobility and logistics costs. When done correctly, upgrades and reactive armor keep the Abrams relevant on modern battlefields for decades to come. Current production of the M1 Abrams focuses on upgrading existing tanks rather than building new ones from scratch. The latest model, the M1 A2 SEP V3, continues to roll off production lines while engineers prepare for the next generation M1 E3 variant. The M1 E3 aims to be lighter, more modular, and easier to maintain, incorporating modern sensors and protection systems. Refurbishment and modernization work is centered at the Joint Systems Manufacturing Center in Lima, Ohio. These ongoing upgrades ensure the Abrams remains a dominant and adaptable main battle tank well into the next decade. Another U.S. weapon that has been in use for decades is the B-52 Stratofortress. Developed during the 1950s, this resilient aircraft can travel nearly 9,000 miles while hauling up to 70,000 pounds of weaponry, a key reason the U.S. military has operated the B-52 for more than 65 years and intends to keep this legendary aircraft flying for decades to come. Over time, the B-52 has received numerous upgrades to address the technological demands of modern warfare. The B-52 requires several hours of ground preparation before taking off. Though every aircraft undergoes pre-flight inspections, the B-52 demands especially thorough checks due to its age. Both ground crews and aircrew carefully examine the bomber's exterior, including its brakes, tires, and engines, and any issue discovered is promptly reported and repaired. During the Vietnam War, the U.S. carried out continuous bombing campaigns with B-52s, losing only 31 of these massive aircraft. This low number was largely because the B-52 could release its payload from the bomb bay almost immediately after takeoff. Originally, the B-52's design allowed it to carry conventional bombs that could be dropped from its two bays onto surface targets. While effective, this configuration did not allow the crew to switch weapon types mid-flight. However, a more recent innovation called the Common Strategic Rotary Launcher, or CSRL, changed that. This new system can carry a wide array of missiles, bombs, and smart munitions, while enabling air crews to switch between weapon types with a simple command. The CSRL not only enhanced firepower, but also greatly improved mission versatility. A key advantage of the rotary launcher system is that B-52s can be fully armed before installation. Loading the CSRL with weapons can take up to 11 hours, after which the launcher is placed on a trailer and towed by a vehicle to the aircraft. Once there, it undergoes meticulous inspection and is positioned directly beneath the bomber's bomb bay. The CSRL is then carefully hoisted and secured inside, followed by the precise closing of the weapons bay doors.
Got it.
In September 2014, the U.S. Air Force showcased its power projection abilities during a nuclear weapons system evaluation program, SORTY. An unarmed AGM-86B air-launched cruise missile, ALCM, was dropped from a B-52 Stratofortress over the Utah Test and Training Range. This operation demonstrated the Air Force's capacity to retrieve an ALCM from storage, load it onto a bomber, simulate a combat mission, and successfully deliver it to its intended target. The U.S. Air Force has also used the B-52 Stratofortress to launch hypersonic test aircraft, such as the Boeing X-51 Waverider. The X-51 is an unmanned scramjet research vehicle capable of reaching speeds of Mach 5, roughly 3,000 miles per hour. True to its name, the Waverider stays aloft by riding the lift created by its own shock waves at high speed. Because it cannot take off from the ground like a regular aircraft, it is deployed from a B-52's left wing rather than from its bomb bay. Despite this, its launch mechanism closely resembles that of conventional weapons. On June 13, 2011, the U.S. Air Force conducted a test flight of the X-51 after releasing it from a B-52 Stratofortress over the Pacific Ocean. The Waverider achieved hypersonic flight, exceeding Mach 5. But the mission ended early when the scramjet engine failed to reach full thrust. After several unsuccessful restart attempts, the aircraft eventually crashed into the Pacific. Beyond the B-52, the U.S. Air Force maintains other bombers, such as the B-1 Lancer, as part of its long-range strike fleet. The B-1 recently received an Integrated Battle System, IBS, a suite combining 3 upgrades: the Fully Integrated Data Link, the Vertical Situation Display Upgrade, VSDU, and the Central Integrated System upgrade. The VSDU modernizes the Lancer's front cockpit by replacing 2 monochrome displays with 4 multifunction color screens, providing pilots and co-pilots with improved situational awareness in an intuitive format. The B-1 Lancer's large bomb bay can accommodate various weapon types. Navy ordnance technicians assemble inert Mark VI 2 quick-strike mines for loading onto the B-1. The arming device is attached to the nose section, while the target detection device, TDD, is fitted at the rear. Explosive ordnance disposal. EOD specialists supervise the entire process to ensure the mines are safely prepared before loading onto the Lancer. The B-1 Lancer houses 3 internal weapon bays and 6 external hardpoints beneath its fuselage for carrying munitions. The crew secures the missile to a loader, which transports it beneath the aircraft. Once positioned under the bomb bay, the missile is carefully lifted and installed. The B-1 can carry up to 75,000 pounds of munitions internally, while the external mounts can hold an additional 59,000 pounds. The B-52, on the other hand, was initially built to carry both nuclear and conventional weapons. However, after the United States signed the Strategic Arms Reduction Treaty with Russia, the B-1 Lancer was permanently restricted from carrying nuclear arms, transforming it into a conventional-only bomber. Periodically, the U.S. Air Force conducts Bomber Task Force (BTF) missions using B-1 Lancers around the world, deploying a range of munitions to enhance combat readiness. These demonstrations send a clear message that the U.S. can project air power with the B-1 anytime, anywhere, in defense of its allies. A reminder to adversaries to think carefully before provoking the U.S. The M1 Abrams and the B-52 both show how careful design, constant upgrades, and skilled crews keep legacy systems lethal and relevant. The Abrams pairs massive protection with mobility and ever-improving electronics to dominate land combat. The B-52 remains a flexible, long-range strike platform thanks to iterative upgrades like the rotary launcher and modern avionics. Together, they illustrate a simple truth of modern warfare: platforms that evolve, survive. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.